Okay, so for 8-3 rotations, this one's pretty short, and it really just goes along with what we've been doing with the reference sheet of translations and reflections. So with rotations, we got to keep two things in mind. Counterclockwise just got that wrong. Clockwise means to the right, so that's how a clock goes, to the right, and counterclockwise goes to the left, so that way. Now with rotations, they are almost always counterclockwise unless stated otherwise, okay? And that note down here. Always counterclockwise unless stated otherwise. That's a very important thing to note here. So a rotation is a turn with respect to a point. So I could take this paper and turn it. I could take it at this point and rotate it. So that would be my point of rotation. Or I could take it at this point and rotate it. And it changes how it rotates. So that's something to keep in mind, okay? Now, the point is usually the origin when working with these. It's almost always, we'll see a 0 right there. And that's even how we wrote it on our reference sheet. We wrote D for degrees. And remember, it's always counterclockwise. And then our origin is usually our point, okay? That's why it says with respect to the origin. And then it has a shape of point in here, okay? Now we just follow these rules. Now, if you notice on the reference sheet, there's two different things. 90 degrees clockwise is the same as 270 counterclockwise. We always want to use the counterclockwise unless the problem states otherwise. So, for example, if I had a problem that said we are going to rotate 270 degrees about the origin, okay, to point P. Let's make point P at -4, -2. Okay, so if I want to rotate 270, I should be looking at the 270 that's counterclockwise, not the 270 that's clockwise. Okay, so I'm looking at this, and my rule says that I need to do y -x. Okay, now that's from xy to that. So that means I have to change the sign on x and then switch x and y, okay? So sometimes I like to do this in 2 steps, okay? I do the first step and say, I'm going to change the sign on x because my x has to change signs. So I know that this is going to be 4, and I'm going to keep that as -2. And then, so that's still my x and y, and then I switch places. So my actual p prime is going to be -2, 4. So that'll be my p prime after that rotation. So I hope that makes a little bit of sense. Now, when we're doing a full shape, like I'm about to show you in the example problems, using this chart that I've gone over, I think I still have my notes on it in here, from translations, doing that same chart over and over again, a pre-image, rule, and image. I don't know where the one for reflections went, but that's what you can do on this. So I'm going to show you that in an example problem in our textbook right here. So this problem, get situated, gives us the vertices. Okay, so I'm going to make my little chart. Make it. I'm going to do the pre-image, the rule, and the image. Okay, I want to write all my pre-image points. It gives them to us. They're actually in black, so I'm going to write them in black. We have P at 1, 1, Q at 3, 3, R at 4, 1, S at 3, 0. Okay, and our rule says that we are going to reflect, and I'm going to put this up here for now, reflect 90 degrees about the origin. Okay, now on our reference sheet, let me pull that out. It says when we reflect 90 degrees about the origin, counterclockwise. Our rule says that we're going to change the sign on y and then switch x and y. Okay, so that's what our rule is telling us to do. Now, what I like to do, like I said, I like to change the sign first. So I like to imagine writing these down with the sign change. So I'm just going to change the sign on all these y's. Now this step is not necessary, but I think it saves from making quite a few mistakes. Can't change the sign on 0. And then now that I've changed the sign on all my y's, I'm going to switch x and y for the final image. P prime, switch x and y, -1, 1, q prime, -3, 3, r prime, -1, 4, and s prime, 0, 3. Okay, so I went ahead and did that so that way you could see the image. Now on this one, it also asks us to graph it out until we can see that happening. This little chart, I think, is very helpful when solving these problems. But that's all I have for 8-3 rotations, so good luck.